Hi everyone. Today we are going to discuss about Euler's number or Napier's constant, named after Leonard Euler and John Napier, which is denoted by E. And we know that E is the hero in our mathematics. And we are going to discuss a brief history about its origin and how it came into being. So let's get started. First of all, uh, there was a need for a function such that f dash x, that is the rate of change of this function with respect to the variable in it, should be equal to fx. And this requirement gave the rise of the need of some kind of function. So we assume that let there be a polynomial function. Now let's differentiate this function once. Now what we can see is that there is a missing term, that is x to the power n, and it cannot be missing since f dash x equal to fx is true for all x. So we need to fill out this term. So one thing is sure, that this polynomial function fx cannot be finite series. Second, its coefficient must be equal. So from second we get a naught is equal to a1 is equal to 2a2, a2 is equal to 3a3, and so on. Now let's define the value of this function at x0 to be 1, and thus substituting the value of a0, we get and so on. So in general we can say that an is equal to 1 by n factorial, that is 1 into 2 into 3 up to n. And now we can write the function as fx equal to x to the power n by n factorial, and summing this up from n equal to 0 to infinity, which will be 1 plus x square by 2 factorial, and so on. Now there were certain properties of this function to find out which will multiply fx with itself, and we'll get the following thing. Now when we multiply this, let's try to guess the coefficient of x cube, and it should be the coefficient of x cube into x to the power 0. Similarly, it should be the coefficient of x square, x to the power 1, x into x square, and x to the power 0 into x cube. Now summing this up, we will get now this looks a bit familiar, and let's rewrite this in some other way. Now where have you seen this? This is the binomial expansion of 2 to the power n. So we can write 2 to the power 3 by 3 factorial, and this will be the term associated with x cube. So the whole term will be x cube 2 to the power 3 by 3 factorial. Now we can take this 2 inside this and obtain this. The same thing can be done with all of the terms, and we are going to see that fx into fx is equal to f of 2x. Now this is a property of an exponential function, and this can be shown that f of 3x can be written as f of 2x into f of x, and this can be proved in the same way as we did above. So this implies that fx is something to the power x. Okay, we don't know this base yet, but to find out this base, what we can do is we can put x equal to 1 in the above equation and get this. Now this is a very fast converging series, since n factorial increases tremendously with increase in n, and the value we get up to 4 terms is quite accurate for the first 2-3 digits. Okay, and this is like the value of it, and we can like say 2.72 for now. This constant appeared in many texts before, but Euler was the one to name it after him, and he proved that this constant is equal to this series, and we call that as e, and hence we get fx is equal to e to the power x, such that f dash x is equal to fx. Thank you for watching this video. I hope you enjoyed. Please like and subscribe for more.